Our very first example of separation of variables. And separation of variables is one of the first methods you learn for solving differential equations. So here to start, let's write y prime as dy dx. So we're looking for a solution y of x. Clearly, y is a function of x. And also because we're given an initial condition, we're looking for a particular solution as opposed to a general solution. Yeah? Okay, so we're going to be able to determine the value of a constant so as to make the solution particular as opposed to general. Yeah? Okay, cool. So that's like, saying like the solution to the differential equation y prime equals 2x is, you can say it's y equals x squared plus c, and that's true. But if I know that like at x equals 1, that y is equal to like 9, then I can find a particular solution, which is, y equals, isn't it x squared plus 8, right? So yeah. All right, all right. So that's what we mean. So we'll be able to find the particular solution. All right, cool. So based on the initial condition. All right. So we write dy dx instead of y prime, and then the right side is like x y cubed divided by, and then it's root 1 plus x squared, right? Now, as the name says, separation of variables, we're going to separate the variables, and we're going to do that by multiplying both sides of the equation by dx on both sides, right? And also dividing both sides by y cubed. Doing both, we can write the following, which is dy over y cubed is equal to, and then it's going to be x divided by root 1 plus x squared dx, right? And now we can integrate both sides. Okay, integrating both sides. The left side we could first write as like integral of y to the negative 3 dy, which we reckon is y to the negative 2 over negative 2 plus some constant, like let's say constant 1, because we anticipate a constant on the right side also. And then here, if you do this using u substitution, you could let like u in here equal like 1 plus x squared. And if you know how to do u substitution, which you should learn before you learn separation of variables, you'll find that this integral is going to be equal to, and it's going to be equal to root 1 plus x squared plus c2. Yeah? Okay, cool. Now what we can do is combine c1 and c2 into a single constant by saying like c2 minus c1 is c, and by doing that we could just write that we've got this situation, that this y to the negative 2 divided by negative 2 equals root 1 plus x squared plus c. Okay, now what we're going to do next is go from this by multiplying both sides of this equation by negative 2, and rewriting that negative 2 times c is k. Doing that, now I'll write in black, we can write y to the negative 2 power is equal to k, which is negative 2 times c, and then minus 2 times root, and then 1 plus x squared, right? Okay, cool. And notice that all that this is saying is y to the negative 2 power is saying is 1 over y squared, so we could just write that. And this is over 1. Now, we can flip both sides of the equation, and it would still be equal. So equality holds if we flip this and flip that. It's equivalent to like cross multiplying and getting to what I'm about to write, which is y squared is equal to 1 divided by, and I like my video so far, so be careful and use a ruler. I'm like annoying about like writing neatly. and this is, ooh, I rushed. I don't need the square root yet. So y squared, flip of this, is 1 divided by, and it's k minus 2 times root 1 plus x squared. Yeah? Okay, cool. And of course, since we're solving for y, all that's left to do here is to take the square root of both sides. And doing that, we can write that y is equal to, or we can say y of x, since we know that y is a function of x. And if we want to show that, we could write y of x, or y is equal to, and we would have written plus or minus, and then the square root of this, right? Because we're getting there, we're getting to this step by taking the square root of both sides of this. So we would have written a plus or minus there, which is why I have a plus or minus right there. But we're going to do the minus because of this initial condition, right? And so then we get minus, and it's going to be square root of what? I don't know if I like that. Square root of, that's better. Square root of what? Well, we already said square root of what? Square root of this. And that is 1 divided by k minus 2 times root 1 plus x squared. Now, if we are looking for a general solution, other than having the plus in addition to the minus, we would be done at this stage. Because, yeah, we found a general solution, but we're looking for a particular solution. And so the initial condition says when x is 0, y is negative 1. So when we plug in 0 in there, we'd get negative 1. So we write negative 1 is equal to negative, and then square root of what? Square root of, well, when we plug in 0 for x in there, we're going to get 1 divided by k minus 2. Well, nice. We cancel the two negatives and then square both sides of what remains, and we'll get 1 on the left side and then 1 over k minus 2 on the right side. That would mean that k minus 2 is equal to 1, which means that k is equal to 3. And that gives us our particular solution, which is that we've got the solution to the differential equation that we have been looking for all along is, well, the same y of x right here, only k we now have determined is 3. So let's get rid of that k right there, replace it with a big fat 3, and then we are done, at least with this part. Yeah? Okay. There it is. So this is our solution. Yeah? Cool. Keep watching.